Okay, in this video we talk about properties and state of a system. Properties and state are concepts of a system, and here's a concept map of thermodynamics. You can see we're talking about things that are related to system and a concept called equilibrium, and we also see process and cycles, etc. I hope this concept map will help you to put the concept that we're talking about in this video in context. A property is basically a thing about the system that we can quantify, and this quantity must be able to measure it or calculate it. A very important thing about the properties is that properties are only defined when the system is in equilibrium. A state is basically a set of properties that define a condition of a system. And in other words, if we know the state of a system, we should know all the properties of the system. And like properties are only defined when the system is in equilibrium, a system only has a well-defined state if and only if when the system is in equilibrium. Now, properties can be divided into extensive properties and intensive properties. Now, first talk about the extensive properties. Extensive properties depend on the extent of the system. So if you divide the system into subsystems, then the properties extensive property should be equal to the sum of that respective extensive property of the individual subsystems. For example, if you divide the system into two halves, then the mass of that system should be equal to the sum of the masses of the two subsystems. And often we use capital letters to represent extensive properties of a system. The intensive properties, they do not depend on the size of the system. Sometimes the intensive properties are only when you divide the extensive properties by the system's mass, and the intensive properties are typically represented using lowercase letters. There are also other intensive properties, such as pressure and the temperature, that do not follow the rule that you divide a extensive property, you get the corresponding intensive property. One thing in common about the intensive properties is that if you divide a system into subsystems, then all the subsystems should have the same intensive properties as the entire system does. This is just one example of intensive and extensive properties. Now let's talk about the continuum assumption, which is also a critical concept in macroscopic thermodynamics. Now that's what we deal with in this course. We deal with macroscopic thermodynamics. And we should know that many concepts and conclusions in this course are only applicable when the continuum assumption is true. Now that's a typo. It should be when. Okay. Should be when. So a macroscopic system is basically a system whose dimensions are much larger than the distance between the molecules in the system. So we also say that this is when the continuum assumption is true. Now, the principles, the relations, concepts we use in this course are generally not applicable in cases where the continuum assumption breaks down. You probably have heard of nanotechnology, micro electromechanical systems, etc. There are systems in which the system's dimensions are comparable to the size or the size of the molecule or the distance of the molecules. In those cases, many of the macroscopic thermodynamic relations no longer hold true. So those cases are beyond the scope of this course. So here is just one example that you can do, and you can see here you have a bottle of soft drink, and you can think of the properties of this soft drink in the bottle, and try to find a few extensive properties, and also try to define a few intensive properties of your system.